Hello everyone, and welcome to PadhaiX. In this video, we'll solve NCERT Class 11 Physics, question number 3.12 from the chapter Motion in a Plane. Let's understand the question first. Imagine a very long hall whose ceiling is 25 meters high. Now, a ball is thrown with a speed of 40 meters per second. The challenge is to find the maximum horizontal distance the ball can travel without touching the ceiling. In other words, we have to choose the angle of projection in such a way that the ball just avoids the ceiling while covering the maximum possible horizontal distance. Let's see how we can solve this interesting projectile motion problem.
Before we start solving the question, let's quickly understand our roadmap. First, we'll revise the basic concepts of projectile motion to understand what controls the horizontal range. Next, we'll check whether the usual 45-degree projection works for this question. If it doesn't, we'll find the maximum possible angle that keeps the ball below the ceiling. And finally, using that angle, we'll calculate the maximum horizontal distance. All right, now let's begin. This is our hall with a 25-meter-high ceiling. All right, for now, let's just focus on the ceiling. Now, as mentioned in the question, a ball is thrown with a speed of 40 meters per second. So let's bring in our cannon, which will launch the ball at exactly 40 meters per second. Now here's our challenge. We have to throw the ball as far as possible without hitting the ceiling. So we'll try launching the ball at different angles and see at which angle it travels the maximum horizontal distance without touching the ceiling. Before we jump straight into the solution, let's quickly revise a few important concepts of projectile motion first. Once we launch the ball at some angle, Earth's gravity immediately starts pulling it downward. This gravitational force produces an acceleration called acceleration due to gravity, or simply g, acting vertically downward. Now, the total time for which the ball remains in the air is called the time of flight. And during this entire time, notice carefully, the ball is moving both horizontally and vertically at the same time. Now, the moment the ball touches the ground again, that's it. Its motion stops in both directions, horizontal as well as vertical. During this entire time of flight, the ball first moves upward and then comes back down. And this maximum vertical distance reached by the ball is called the maximum height of the projectile. Similarly, during the same time of flight, the ball also keeps moving forward in the horizontal direction. And this horizontal distance covered by the ball is called the horizontal range of the projectile. So, whenever we study projectile motion, we usually break the motion into two separate parts, the horizontal component and the vertical component. This is the velocity of the ball, and we can split this velocity into two components. The first one is the horizontal velocity. And the second one is the vertical velocity of the ball. At the same time, don't forget, gravity is continuously pulling the ball downward with an acceleration g. Now, let's focus only on the vertical direction first. In the vertical direction, the ball has an upward vertical velocity, while the acceleration due to gravity acts downward. So basically, these two are acting in opposite directions. Now, let's shift our attention to the horizontal direction. Here, we only have the horizontal velocity. Notice something interesting. There is no force acting on the ball horizontally, and because there is no horizontal force, there is no horizontal acceleration either. So, this makes our job much easier. We can simplify the equations of motion along the horizontal, or simply the x direction. Along the horizontal direction, the acceleration is 0. Now, if we substitute a equals 0 into the equations of motion, here's what we get. V equals u. V square equals u square. And S equals u multiplied by t. These are the equations of motion along the horizontal direction. Now, here's the most important observation. Since the initial velocity is equal to the final velocity, the horizontal velocity of the ball remains constant throughout its entire journey. And because the horizontal velocity remains constant, the horizontal distance traveled, which is also called the range of the projectile, is simply equal to horizontal velocity multiplied by the time of flight. Now, think about this for a moment. Since the horizontal speed is already fixed, what actually decides how far the projectile will travel? Well, it's the time of flight. In other words, the longer the ball stays in the air, the farther it keeps traveling horizontally. So, the longer the time of flight, the greater the horizontal range. Now, the next question naturally comes up. What determines the time of flight? Well, the time of flight depends on how high the ball goes while being launched with the same speed. It's quite simple, actually. The higher the ball rises, the longer it takes to come back down. And because it remains in the air for a longer time, its time of flight increases. Now, let's understand this with a simple example. Suppose we throw the ball almost in a straight line from the ground. It comes back down very quickly. Since the ball hardly moves upward, its time of flight is very small. Now, let's increase the angle of projection just a little bit. Watch carefully. You can already see that the range is increasing. But why is that happening? Because now the ball rises higher. It stays in the air for a longer time. And during this extra time, it continues traveling farther and farther in the horizontal direction. Now, here's an interesting question. At what angle should we project the ball so that it travels the maximum horizontal distance? Well, if you've studied projectile motion before, you probably already know the answer. It's 45 degrees. A simple rule to remember is, whenever a projectile is launched at 45 degrees, its horizontal range is maximum. But, wait a second, there's a catch in our question. We have a very important constraint. The ceiling of the hall is only 25 meters high. So now we have to check something. If we launch the ball at 45 degrees, will it clear the ceiling or will it hit it? Let's find out. To answer that, we'll use the formula for the maximum height of a projectile. And the formula is h equals u squared multiplied by sine square theta divided by 2g. Now, let's substitute the given values. So we get h equals 40 squared multiplied by sine square 45 degrees divided by 2 into 10. Now, we know that sine 45 degrees is 1 upon root 2, so the equation becomes h equals 40 squared multiplied by 1 upon root 2 whole square divided by 2 into 10. And after solving this, we get h equals 40 meters. Now look at this carefully. If we launch the ball at 45 degrees, the ball reaches a maximum height of 40 meters. But our hall's ceiling is only 25 meters high. So what does that mean? It means if we throw the ball at 45 degrees, it will definitely hit the ceiling. And that's exactly what we have to avoid. So instead, we'll launch the ball in such a way that its maximum height is exactly 25 meters. Now our goal becomes very clear. We need to find the angle of projection at which the ball reaches a maximum height of 25 meters. So, let's bring back the maximum height formula. Now the equation becomes 25 equals 40 squared multiplied by sine square theta divided by 2 into 10. After rearranging the equation, we get sine square theta equals 25 multiplied by 2 multiplied by 10 divided by 1600. Now let's simplify it. This becomes 5 divided by 16, which is 0.306. Now, taking the square root of both sides, we get sine theta equals root of 0.306, which is approximately 0.55. Finally, theta equals sine inverse of 0.55, and that gives us 33.6 degrees. So here's the answer we've been looking for. If we launch the projectile at an angle of 33.6 degrees, it will travel the maximum possible horizontal distance without hitting the ceiling. All right, now that we've found the correct angle of projection, let's calculate the maximum horizontal range. The formula for horizontal range is r equals u squared multiplied by sine 2 theta divided by g. Now, let's substitute all the values. So we get r equals 40 squared multiplied by sine of 2 into 33.6 degrees divided by 10. Now, simplifying this, it becomes 1600 multiplied by sine 67.2 degrees divided by 10. And we know that sine 67.2 degrees is approximately 0.92. So, the horizontal distance becomes 150.5 meters. And that's our final answer. So the maximum horizontal distance that the ball can travel without hitting the ceiling is 150.5 meters. Now, before we wrap up, let me tell you something interesting. There is another way to solve this question as well. Instead of using the range formula directly, you can first calculate the time of flight and then simply multiply it by the horizontal velocity of the projectile. Since we've already learned that horizontal velocity times time of flight, both methods will lead you to the same final answer. You can try solving it using that approach as a practice exercise. And with that, we've successfully solved NCERT Class 11 Physics Chapter 3, Question 3.12. I hope you not only understood how to solve this question, but also why we couldn't use the usual 45-degree rule here. That one extra condition, the 25-meter ceiling, completely changed the approach. And that's exactly what makes physics so interesting. If you found this explanation helpful, please hit the like button, share this video with your friends, and don't forget to subscribe to PadhaiX for more visual and easy-to-understand NCERT physics solutions. Thank you so much for watching, and I'll see you in the next video. Until then, keep learning, keep exploring, and keep enjoying physics.